students out of the paper, right? So if we use the Fleming's left hand rule, then it's going to be looking like this, that the force is going to be acting downwards. So magnetic force acts downwards, right? So the question is, if both fields are applied simultaneously, and this force, magnetic force and electric force, they become equal, then what's going to happen? The charge is going to go straight, undeflected. Undeflected. Then there is going to be some mathematics which is not needed for you people. Why? Because we just, but this could be asked in exam. So let's start doing it. Like this is the magnetic force, and since this is the electric force, so what Q is cancelled. So we are left with like finding out the speed, which is electric field strength divided by magnetic field strength. So this is the main formula of the velocity selector, right? And if we like reverse the direction of B, there is not going to be any change, or there could be any change. Like only B is reversed. So what's going to be happening then? Then magnetic force and electric force both are going to be upward. So balance point cannot be found out. Right? So, okay, now if we talk about like this thing, when the direction of B is reversed and both are in the same direction, then the total force will be upwards. And that total force, like the total force, which is equal to like electric force plus magnetic force. So a scientist Lorentz first calculated it to be, and he called it the Lorentz force. Like, what is electric force? This. What is magnetic force? This. So this is the Lorentz force formula. And if you like take Q, the common, then it's going to be like this, E plus VB. So students, this is the force that was not in A levels, but here you need to do it for the entrance test exam, right? Okay. So it's E over M ratio of the electron. Like, what is this? This is basically charge to mass ratio. Now, one thing the FSC students must remember, because the A levels, I already know about it, that this is also called specific charge. Like the charge to mass ratio, it is called what? Specific charge, like charge per unit mass. And what was the formula of this, students? There were two formulas. Like the first was V by BR, and the final one was, students, 2V by B square R square. So mathematical proof is not needed. We just need to know that what are the variables. Like, students, Q is the charge on electron, which is like simply easy. Small v is, students, speed. Capital V is the potential difference. And R is the radius of the circle, while B is the magnetic field strength. Right, students? So remember that this V is small v, this is speed, and this V is potential difference. And students, M is definitely the mass of electron, whose value must be remembered. Like, how much is it? 9.1 times 10 to the power negative 31 kgs. Right, students? Okay, students, next. CRO. All of you know about CRO. Let's talk about it. Like the parts of the CRO are like F is called the filament, G is the grid, and what is like CC is the cathode, and this whole thing, students, is called electron gun. This is called what? Electron gun. And the process by which the electrons are emitted from it by heating them, students, this is called thermionic emission. So you have studied it from the junior levels as well. And now what are these things? 1 minute, students. Sorry, students, I just dropped out. So let's start again. Like we were here, students, at the CRO, and I was telling you that what is thermionic emission. And then, students, what are these things? These A's, like A1, A2, and A3, these are like 3 anodes. You studied it to be like just 1 anode, but actually there are 3 ones, right? And there are like plates, XX, horizontal deflection plates. Horizontal deflection plates means that how the charges are going to be deflecting. Like let's say if the electron beam is coming from here and we make this is to be the positive plate and this to be the negative plate, then the electrons are going to be bending towards left, right, students? And if we talk about like, so this is what? This is horizontal deflection. And what about YY plates? If I make the lower plate to be positive and upper plate to be the negative, then electron is going to be bending downwards. So this is like vertical deflection plates, right, students? And students, this S is the fluorescent screen. Fluorescent screen is basically, you know that it is a material which glows when a moving charge hits it, right, students? Okay. So this is the all the things that are written here that I have already told you about. Now, most important thing is that what is the waveform that is applied to the CRO for having a display on the fluorescent screen. So that waveform is called sawtooth voltage waveform. Now, let me tell you a little difference between all these like waveforms. They're different strips. Like if we talk about the simplest waveform, students, that is this one. Since we call it square waveform. What? Square voltage. And the second one is this, 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 and this. Now don't mix voltage number A and C. So they are totally different. This is called triangular waveform, right? And what about this? This is sawtooth waveform. Like this line is straight. Have a look at it. That since this line is not slanting, this is rather straight, right? So this is making the sawtooth waveform. Okay, this is totally different from the triangular waveform. And the most frequently used waveform is sinusoidal waveform that you always use in waves. So students, this is sinusoidal. And this is square wave. And this is triangular, and this is sawtooth. So in CRO, what type of waveform is used as an input? Sawtooth waveform, right? Okay. Uses of CRO. Yes, sir. It is used by the amplitude. You have studied it in A levels. Time period, frequency is determined using the time period, and the last thing is the phase difference, or the phase angle between the two waves. That was the detailed topic of AS physics, right? Okay. So if we talk about, students, the torque of the current carrying coil, you have also studied it in your A2 physics. And what was that? If we have this coil, which is a current carrying coil, a current carrying coil which is placed inside the magnetic field, then what happens? Two equal and opposite forces tend to rotate it. So it creates a couple, or the moment, torque of a couple or moment, right? They create it and the coil starts rotating. And what's the formula for that, students? The formula is like BIA cos theta. Now, what are these variables? F is definitely, sorry, this is the force. This is not the force, this is torque. Right? So T is what? Torque or couple. B is what, students? Magnetic field strength or magnetic flux density. And what is I? It is current. And students, what is A? It is the area of coil. And theta is what? It is the angle between B and A. Right, students? And this is the formula. Let me tell you that this is the formula when we have only one turn of the coil. This is the formula of the torque of one turn of the coil. And if we have like n number of turns of the coil, like this, like let's say, students, we have a thing like this, like different number of turns of the coil. This and so here is, let's say, the coil with different number of turns, like n turns. Then students, the same formula will be simply multiplied by n. So it will like become BIA cos theta times n. So students, torque is going to be what? BINA times cos theta. Right, students? Okay, 4 minutes are left, so we couldn't complete this chapter today, and we cannot start the next topic because we are left with like so much less time. So students, we are going to start the galvanometer in tomorrow's class. Right, students? Okay then, see you tomorrow. Allah Hafiz.